Looking at a question like number 4 with the slope field right there, I see that dy dx essentially only depends on x. So when all is said and done, you should have what sort of a pattern?
Parabola.
Well, yes, but as far as the slope field marks, should be a vertical pattern. So in other words, every single slope field mark in a vertical column should be exactly the same. And overall, you're right, this does end up being a parabola. I can show that to you a little bit if you want. Okay, so if you're going to do a table of values, which could be a good strategy here, I'm going to do something like that. My inputs are x's, my outputs are dy dx's, and so maybe the first one you plug in is 0. That makes a lot of sense. So dy dx would be 0 when x is 0. So a 0 slope means horizontal, right? Flat. And so whenever x is 0, which is the y-axis, you should have flat slope field marks. So something like that, and that, and that. There we go. Look reasonable? Okay. So when you plug in a 1, 2 times 1, of course, is 2. So the slope would be 2. What I was sharing with a couple of folks over here, if I'm going to try to replicate a slope of 2, like let's say that my goal is to put a slope field mark right there. Like what should I be aiming at if I want to have a slope of 2? The origin, yeah. If I aim right there, then I'll have, that's an up 2 over 1 type of a pattern. Again, it does not have to be perfect, but if I'm shooting for that slope of 2, I'll say something like that. I'm trying to point it right at the origin. Now, of course, in that whole vertical column, you're going to have the exact same slopes. So I'm kind of just try to be as parallel with that one as I can. I don't like that last one. I'm going to go with, that's pretty good. Whoops. Come on. Like that. It's hard to write with this marker. Okay, and then when x is 2, slope is 4. So as I move over to the right, this gets tough, right? Because it gets steeper. The steeper they get, the tougher they are. We'll talk about how I would grade this, but I'm going to put something like this and this. About like that. So can you guys see? Does it, you can agree or disagree, I don't know. Can you guys see a pattern where all of the slopes in the column at x equals 1 and all the slopes in the column at x equals 2, you see a steepening pattern as you go to the right? Yeah. That's what we want to see here, right? So whether your slopes are perfectly representative of 2 and 4, I'm not that concerned about that. Obviously, we could have positive slopes there, but if I see a steepening pattern, I'm pretty happy with that. And then, of course, when x is 3, slope is 6. So that's going to be even steeper. It's going to appear to almost be vertical. It's pretty hard to draw. Maybe something like that. Again, we're looking for a steepening pattern as we go to the right. And then on the negative side, of course, you're going to have something similar going on. When x is -1, slope is -2. And so it's going to have some nice symmetry here. Like that. When x is -2, slope is -4. Maybe something like that. And finally, when x is -3, slope is -6. So it's going to be, again, almost reaching a vertical slope. At least it's going to look that way. Maybe something like that. Okay, do you guys have any questions? Did that go okay for you? Doug, Dan, Mark, you guys all okay with that? I want to dig a little bit deeper with this one. Is that okay? Okay, so let's do something that you guys know how to do, and I think you're pretty good at it. Let's take that differential equation, dy dx equals 2x, and let's solve it for its general solution. We've done this before, right? So if you're going to solve the differential equation, what is the first step that you got to show? That's right. So that's what I'm going to do. So I'm going to write it as dy equals 2x dx. Once you've separated the variables, what comes next? Yep, so we integrate here and here. So y is equal to x squared plus c. Okay. So you can see, just like you probably already saw this, Austin mentioned it, that it looks like a parabola, right? Can you kind of see the parabola within the slope field? Okay, so what I'm about to show you is a pretty key thing. So we've got this, parabola. We see the idea that, the general solution is going to be a parabola. Let's say that you were instructed to do this. I'll put this in a different color. Let's say it said, draw a solution curve through, 1, -1. Draw a solution curve through 1, -1. What they're asking you to do then is draw the curve that would produce this slope field, specifically going through that point. So that's kind of like the initial condition, right? 1, -1 would allow you to find the C. So I want to basically instruct you on how to do this and how not to do this. So I'm going to try to be really, really careful here. So 1, -1 is right there. And so I need to make sure that my solution curve goes through that point. So here would be my attempt at that. And the other half would do something like that. Does that look pretty reasonable? So there's a couple things that I think are worth mentioning here. I'm clearly making an attempt to go through that initial condition point, right? And we know enough about parabolas to know that there's symmetry on this one. And so doesn't it kind of have to go through that point as well? Typically, we want our solution curve to only go through the initial condition because there's no guarantee, other than the fact that we know a lot about parabolas, there's no guarantee that it'll go through some other point. So what this is not is connect the dots. Okay, so if you're supposed to draw a solution curve, it is definitely not connect the dots. It's touch one dot and then make sure you follow the pattern of the slope field. So please don't seek to connect all the dots. I'm going through the initial condition, so I'd say that's pretty reasonable. And yeah, it does look parabolic in shape. The general solution seems to confirm that. That'll be something from time to time that you're asked to do. That solution curve needs to be a function, and this one pretty obviously is a function, right? Parabola function. Okay, we'll do maybe one other solution curve, but I thought I'd show you on this one. This one is pretty straightforward. You guys have any questions? Okay, so far, all of our slope fields have either depended on y or x. So let's review this. If your slope field depends on y, then the pattern will always be horizontal. If on x, then it'll be vertical. If the slope depends on x and y, you're going to get some kind of a funky diagonally pattern, and that's what we're going to look at right now. So let's take a look at 6. Yeah, let's take a look at number 6. Let me table like you've never seen before. Okay, so dy dx equals -y over x. Okay, so before what we had was an input of x and an output of dy dx, or an input of y and an output of dy dx. For this, if we're going to make a table, and we're not going to make a table for all of it because it would just be too gigantic of a table, we're going to start trying to see patterns here before too long. But what I'm going to do is a 3-columned table. Oops, how about this? Like this. X and y and dy dx. So x and y are both inputs, dy dx is your output. We're going to try to fill out this table and we'll get our slope field put in. Let's do this to make it a little bit easier on ourselves. Can we just eliminate these outer bands?
Yeah, sure.
Let's do that. That'll make it a square, right? It'll make it just one fewer thing. So let's not put anything out there. We're just reducing the size of the slope field just for time considerations. Okay. So let's just start off with maybe some points that might seem logical to you. Like what would be an x and a y? 0, 0. Cool. So if we do 0, 0, I'm going to write really small here so that we have lots of room. 0, 0, what's dy dx there? Undefined. You can't divide by 0. So that's a good one to think about, but it's not going to produce any slope fields. I think we could generalize this and say that whenever something is 0, you'll get dne. What is that something? Whenever x is 0, you'll get dne, right? You can't divide by 0. So when x is 0, that's the y-axis, right? Okay, so let's just kind of file that one away. We're not going to be plugging in a 0 for x ever. So 0, 0 is probably wise to start off with. What would be another wise option? 1, 1, all right. So 1, 1, the slope would be? Negative 1. So right there, I'll do my best to do a negative 1 slope. Something like that. So typically these slope fields are pretty small as far as the number of points, maybe like 9 or 10. Simply, you can see how this could get really time consuming to do 1 point at a time. We should be able to see some patterns emerge pretty quickly. 1, 1 was smart. What's another smart one you can think of? 1, 0. Okay, we go with 1, 0. And what did you say, Titus?
2, 2.
2, 2. Okay, let's do both of those. So 1, 0 would give us 0. Yeah. Okay, so 1, 0 over here looks like that right there. Interesting. 1, 0, the slope is 0. 2, 2, the slope is? Negative 1. Okay, so 2, 2 would be right there. So I'm seeing an interesting pattern starting to take shape. You seeing a diagonal pattern maybe? How could we confirm? Like, what would you expect possibly to see over here?
Positive 1.
Let's find out. So those points would be like negative 1, and negative 2, negative 2. What's that? You take it back. What do you think it is now?
Positive. Or I mean negative 1.
Negative 1. Yeah, I think for both. So, you know, you're starting to see a diagonal pattern emerge. So there should be some level of symmetry with many of these. So what would you guys think is going to appear on this diagonal right here? Maybe a slope of positive 1? Let's confirm that. So one of those points would be, you know, maybe like 1, negative 1. Oops. So when you use 1, negative 1, is your slope positive 1? It is, yes. Now, maybe mentally do those other points, you know, so like negative 1, 1 and negative 2, 2. You should see a slope of positive 1 emerging on all those that see it. Okay, I think seeing the patterns is really key because otherwise these all just end up being 1 by 1 by 1 and it takes forever. Okay, so slope of 1. How about this and this? Skipping over the origin. And how about that? Starting to look kind of interesting. Kind of an X pattern going on there. Well, but okay, now I get why you'd say a circle, but what's the point that tells us that it doesn't look like a circle? Yeah, the one there at 1, 0, I'd say that does not indicate a circle, right? So let's keep going. I think we can gain a pattern based on that idea. When will the slope always be 0? Not when x is 0, but when y is 0, right? So whenever y is 0, doesn't really matter what x is except for 0, the slope will be 0. So I think we could put in these little horizontal slopes everywhere there except for the origin. This is definitely not looking like a circle at this point. You see we created a lot of symmetry here. We might be able to kind of mirror image some things and see a pattern. You can always plot points to see for sure. Why don't we do, how about 2, 1? Let's see what happens over there. It's the first quadrant, 2, 1. When I plug in 2, 1, what do you see happening? Negative 1 half, yeah. So negative 1 half. So that's got to be less steep than the one there to its left. So I'm going to say that's probably too much. Something like that, maybe. Okay. So do you see that mirror image of that point in the other 3 quadrants? Let's just do a quick mental check. I mean, what if we think about this one over here? That would be negative 2, 1. What do you think that slope will be there? 1 half, right? So seeing a little bit of a pattern emerge, maybe. So 1 half would be about like that. And then what would you guys guess is going to happen at these 2 down here? Some version of 1 half, right? So in the fourth quadrant there, I would say positive 1/2. So, and then over here, negative 1/2. Starting to take shape, not too bad. There's 4 more points. Let's see if we can figure out the pattern. How about the point 1, 2?
It's 2.
1, 2, I think would be negative 2. Yep. Okay, so negative 2 will be the steepest on this one. So it's going to look about like that. And then if we mirror image these, I think maybe you can start to see these patterns emerge quicker than I can, or as quick as I can. But I think that second quadrant one will be that. Third quadrant one will be this. Fourth quadrant will be that right there. We've got them all. So this is kind of an interesting one as far as what's the solution curve, right? It's kind of different looking. Let's show you here. Let's do it like this. This would be a good one for us to think about as far as solution curves and drawing them. So let's do this. Let's say sketch a solution curve through -1, -1. So, of course, that's right here. Sketch a solution curve through -1, -1. Let me give you just a minute to think that through, what you think that might look like. And I'll put it up there. We can talk about, obviously going to have some curviness to it, right? It's got to go through that point. And be a function. Okay, so for a solution curve, I would suggest this. I'll do my best. Let's try that again. What do you guys think? Got a curve to it right there. Let's talk about some things that are going on here. What do you guys see happening on the x-axis? Yeah, horizontal asymptote. Think about this. If I really can't cross over that here, because if I did, doesn't this part right here, doesn't that disagree with the slope field? All the slope fields in the second quadrant are positive. That one's negative. It's not going to agree with it. So I really can't cross over that horizontal asymptote. What do you guys see going on the y-axis? Vertical, right? Vertical asymptote. Yeah. So we are going to stop right there and not going to graph any further to the right because you can't cross that vertical asymptote. A few other things to talk about. Let's try to see what this is as far as separating the variables, like we talked about earlier. If we're going to separate the variables, this gets a little more complicated. Do you guys know what you would do to separate the variables? Multiply by dx, I agree. So if we did that, we would get dy equals negative y over x dx. So we're still not there with the separation of variables. What would I need to do? Move it by doing what? How do we get the y over? Dividing, yeah. We divide both sides by y. So I'd end up with dy over y equals dx, negative dx, over x. Right? Okay. What comes next? Say again? We can definitely do that one. Don't we integrate? Don't we find the antiderivatives? So what is the antiderivative of dy over y?
Oh.
What is it?
Natural log of
Natural log, yeah. So you'd get ln of y equals, yes, negative ln of x plus c. Now plus c is quite important. So if we're going to try to get that y by itself, wouldn't we need to go e to both sides? solve the equation for y. So if we go e to both sides, we end up with absolute value of y equals e to the negative ln of x plus c. So this is one of those e things, right?
Oh boy.
Yeah.
Can you zoom in on that?
Zoom in on what?
Your word, because I can't even read it.
Yeah, I'm sorry, I can't zoom in on the video program. I can, so I'm zoomed in, but it doesn't zoom in up there. Yeah, which part are you looking at?
The absolute value of y.
So it's absolute value of y equals e to the negative ln of x plus c. Is that better?
Yeah.
Okay. It's in the exponent. It's in the exponent, yeah. So I'm not too concerned about this right now. This is going to be something else we work on in chapter 6. We just have a very, very different looking graph, right? This is something kind of new. It can get pretty complicated pretty fast. All right. So here's what I think I want to do. We've got one. Do we have one more slope field to go? It's number 4? 3? 3? Okay. So if it's okay with you, can we save number 3 for in a future class, just as a way of coming back and reviewing and warming up? Let's do this. Oh, no, please don't pack up. I want to show you one example of a test question. A test question could be draw the slope field. That's a pretty nice test question. You draw the slope field. Hopefully you can get 2 points out of that. But there are some other ways these questions could be asked. So let's just look at one of those, and then we'll be done with our notes for the day. There are very quick ways to decipher this. You should have it in your notes. You got to have it in your notes. You can look up here with me though. So it says match the slope fields with their differential equations. So 7 through 10 give you some dy dx equals whatever's, and then it gives you these slope fields trying to match those letters with those numbers with the slope fields there. If you think about patterns, the horizontal and vertical, you can make some answers pretty quick. And there might be a few that take you just a minute longer. So I want you to try this. Give you a couple of moments here to try it. I think you can do this. I really do. So give it a shot and see what you come up with. Feel free to discuss as well. So would it be fair to say that, at first glance, like if you look, the moment you look at this, like your heart rate goes from like 65 to like 135? Because you see all the little marks. I mean, honestly, you look at that and you're just like, oh my gosh, there's so many marks and they're all going different directions. It's easy to get into a panic, right? Maybe you felt that. I know that I have felt that, looking at these for the first time, in the past, thinking, wow, there's marks going everywhere. But if you start to ask yourself strategic questions, you can actually start to break this down. For example, I'm going to look at this one and this one. Those are cases where dy dx only depends on x, right? So those should have some kind of a vertical pattern element. Number 9, dy dx only depends on y, so that should have some kind of a horizontal pattern, right? And then number 8 has both x and y, so it should have kind of the diagonally thing going on, not vertical nor horizontal. So that would be a quick way to start deciphering what goes where and looking along the lines of those. So let's just hear what you got here, Mark. What do you have for number 7?
Let's see. I think it's C.
Okay. We'll go down the list here and see if we agree. Doug, how about number 8 for you? What do you think that is?
D.
D. All right. Dan, how about number 9? What do you have for that?
I was going to say A.
A. And so then, Chloe, Madison, you guys agree that B would be 10?
Yes.
You guys came to an agreement back there? Okay. So in order, CDAB. C-D-A-B. There we go. I knew I could get you to do that. Isn't that amazing? All right. So is there agreement on that? You guys see C-D-A-B? Okay. So let me ask you a question. This numbers 10 and 7 both shared the vertical pattern, right? So, to me, like number 9 is really clear cut. There's only one horizontal pattern up there. It's got to go with 9, right? Okay, and then number 8 has x and y, so it's got to be the crazy diagonal thing. That only makes sense with D. How did you guys differentiate between 7 and 10 being C and B or B and C?
Wavy.
Okay, so wavy thing, I think that's an intelligent observation that you know that the derivative of cosine is sine and they're both the wavy thing. That's a pretty intelligent observation, and I would say that's pretty good here. But what if you were having a weak moment and, I don't know, you didn't think about that, you didn't notice it, you're just like, oh my gosh, 8 and 9 DNA, that seems pretty clear, but I don't know about 7 and 10, C and B, B and C. What you could do is you could do a quick little test value or two. So maybe you look at number 10 and you do a quick input-output. You say, all right, for number 10, when x is 1, dy dx would be 1, right? So then you look at B and C and you try to find, okay, when x is 1, all right, so when x is 1, we'd be looking at this and this. And it doesn't really tell you an answer, does it? They're both 1. So you think, okay. I don't know if that helped me as much as I wanted it to. Maybe we try a 2. So when you try a 2, dy dx, I'm looking at number 10 here. If you try a 2, dy dx would be 2. Okay, so then I look over here on B and I kind of plot those out. Now that's steeper than the one on the left, isn't it? So that might work. I look at this. Those appear to be just about parallel, don't they? So that's going to get me start leaning towards B, right? Maybe we do one more just to be sure. When x is 3, then dy dx is 3. Now I think the case for B gets even stronger, right? Because here we see a negative slope. So that tells me that it's not C. B looks a lot more reasonable now. So you could plot a couple of points and look at some patterns and say, yeah, I think that's what it is. Based on just the wavy thing is a good idea. But if you didn't see it, you can always plot a few points, plot a few patterns, and that should tell you what you need to know there. So there's other ones like that coming up. We'll just do those next week. For now, let's put the rest of the notes on hold, and we'll move on to new stuff. So.